We're asked to find a system of linear equations with three unknowns, x, y, z, whose solution is x equals 1, y equals 2, and z equals -1. So these are the conditions that the equations must meet. And here we've been given the solution, so we are free to come up with any system that satisfies this. Uh, a simple idea for doing this is if x equals 1 and y equals 2 and z is -1, then what is the value of x plus y plus z? What is it equal to? Well, it's as simple as x plus y plus z equals 1 plus 2 minus 1, which is equal to 2. It means that x plus y plus z equals 2. So that is one equation. Another equation is we just have to get any combination of x and y and z that we want. And that's going to give us another equation. So if we write 3x plus 2y minus z, what is that? Well, 3x is 3, 2y is 4, so 3 plus 4 is 7. Z is -1, so minus z is 7 minus 1, and that is 8. So that gives us a second equation. The first equation is this, and then we can get a third equation again with any combination of x, y, and z. So let's say we get x minus y plus z, right? That's going to give us another combination. So what is x minus y? X is 1, y is 2, z is -1. So 1 minus 2, that's -1, and then plus z, which is another 1, so we have -2. So that's our third equation. So these three equations, if you solve them simultaneously, you're going to get x equals 1, y equals 2, and z equals -1. And we can do a quick check just to confirm for fun. So let's say we write these equations. So we have x plus y plus z equals 2. Then we have 3x plus 2y minus z equals 8. And then we have x minus y plus z equals -2. Assuming we wanted to solve the system of equations simultaneously, what could we do? Let's say we want to use elimination. So we could subtract 3 times equation 1. Let's call this equation 1. We call this equation 2. We call this equation 3. So we subtract 3 times equation 1 from equation 2. So let me just draw a line here. We have equation 2 minus 3 times equation 1. What does that give us? We have 3x minus 3x, so the x's go away. Then we have 2y minus 3y, that's minus y. And then we have minus z minus 3z, that's minus 4z. And that's equal to 8 minus 3 times 2, that's 6. So 8 minus 6, that's 2. So that's our new equation. And then we can eliminate x from equation 3 as well. And we do that just by subtracting equation 1 from equation 3. So equation 3 minus equation 1, what does that give us? Well, x minus x, so the x's go away. Then we have minus y, that's minus 2y. And then we have z minus z, that's just the z's go away. And then on the right side, we have minus 2 minus 2, that's minus 4. So we have minus 2y equals minus 4. What does that mean? It means that y equals 2. So by eliminating x from equation 3, we are left with y equals 2. And we can use this y equals 2. If we substitute that into this equation, what does it give us? We get minus y, which is minus 2. Then we have minus 4z equals 2. So this means that minus 4z equals 2 plus 2, which is 4. So z equals minus 1. So we have y equals 2. We have z equals minus 1. So now we want x. And we can get x by substituting these two values into any of these equations. Let's substitute into equation 1. If we do that, what do we get? X plus y plus z equals 2. So x plus y, but y is 2, and then plus z is minus 1. This is supposed to be equal to 2. So what does that give us? That gives us x equals 1. And that is precisely what we started with. We wanted x to be equal to 1, y to be equal to 2, and z to be equal to minus 1. So we combined them, we got these three equations, and then we try to solve these equations to see if we're going to end up with the result that we started with, the result that we wanted to get from the beginning. And it checks out. So let's go to okay, let's pause here. We'll solve another question in the next video. See you later.